These are what are called guided notes. So, what I'm going to do is basically give you an outline, some of the key equations, the definitions you need in order to do well on your quiz. Now, if you have one of these for each of our modules, you should be in really good shape when it comes to the final exam. So, we have some equations that we go over. We will go over capital M molarity, which is moles of solute over liters of solution. We will go over lowercase m or molality. This is commonly used in biological applications. So that is moles of solute divided by kilograms of solvent. You will need to know X. Now, X is going to be what's called the mole fraction, and that's going to be moles of solute over total moles in the system. We also have percent mass. So these are our concentration equations. So percent mass is going to be 100 times the mass of the solute divided by mass of the solution. So this would be a good time to point out, well, what is the solute, the solvent, and the solution? Well, those are definitions that you should be able to come up with. So solvent and solution. We will also talk about delta TF being equal to I, KF, and lowercase m, the molality. Now, if you don't know what any of these variables are, this is a great spot in order to write those out. So lowercase m being molality, I, how do you find I? You'll need to know that as well. And the KF, now you also may want to color code. So what I like to do is I like to highlight in a color. Oftentimes I will choose yellow as my default first color. And that's going to be a tabulated or a constant that you're going to find somewhere either in the problem or on the quiz itself. I needs to be calculated. And because I needs to be calculated, I would use a different color for that. And how do I calculate that I? So this is how I would set up, again, guided notes. So similar, we have delta TB, which is I, KBM. I would use the same highlighting convention there. Pi, the osmotic pressure, is going to be equal to capital M, that is molarity, times R times T. R is the universal gas constant, and what we're going to use in this module is 0.08206. And you might want to write down those units as well: liters, atmospheres, mole, Kelvin. So your T is in Kelvin here. Okay. What else do we have? We have other definitions. So you will need to know what the word miscible means. You will need to understand what intermolecular forces are, be able to put them in order from weakest to strongest or strongest from weakest. You'll have to pay attention to what your question says. Also have examples of each of those intermolecular forces. Be able to define concentration. There we go, tration. Also solubility. What does that mean? And can you describe it in terms of intermolecular forces? Be able to define electrolyte as well as colloid and saturated solution. And then also with saturated, be able to define unsaturated as well as saturated, supersaturated. So things you might want to review or remember. How do you tell the difference, and when do you know if you have an ionic compound versus a covalent compound? Okay. How do you know the molecular polarity? Do you remember that? Do you need a review? Do you remember how to calculate moles from grams or from its mass or from its volume, milliliters? Do you know how to use density in order to calculate or convert volume to mass, mass to volume? And also chemical formula stoichiometry. Now, specifically, when I say chemical formula stoichiometry, what I mean is, can you look at H2O and tell me that for every 2 moles of H, you have 1 mole of oxygen? Can you calculate molar mass? Okay, molar mass you need to go to the periodic table for. So this is an example of what are called guided notes, and you would write down everything you need as you're going through the lecture. There's this big problem-solving area, and then if I was doing this on a physical piece of paper, I would also use the back for that problem solving. And then that should be your notes moving forward in the course.